Hello everybody, and thank you for joining me. We're looking at question number 19 on our 2010 grade 11 Fermat paper. In the diagram, PQ equals QR equals RS equals SP equals SQ. That is a lot. Okay. PQ, QR, RS, SP, and QS. Okay, so I've got a few equilateral triangles hidden in here. Oh, and that length is always 6. Okay. And I know PT is equal to RT, and that's equal to 14. The length of ST is... Okay, the length of ST is... Well, we've got some numbers. We have a whole lot of information. I'm really liking the picture here. It's kind of lopsided. Draw a better one. ST, so I've got 14, 14, 6, 6, 6, 6, 6. Alright, and I need to figure out ST. ST is the length I want. Now, there's a great deal of symmetry in this question. There's two equilateral triangles stuck together, and then sort of an isosceles triangle sort of overlapping that. In fact, I think I'm going to use this isosceles triangle. Drop a little perpendicular down here, and then P, there's Q, R, S, and T. So PRS is a nice little isosceles triangle. Okay. And ST is going to lie as part of the altitude of that triangle. We're going to get a nice little right angle here. And so you can see this because T to this base point that I'll call U is going to be a right angle, but S to U is also going to be a nice little right angle by symmetry. And so PU is an altitude of my top equilateral triangle, and RU is an altitude as well. But we can figure out these heights of these triangles. And if I know what PU is, then I can use the 14 over here and Pythagoras' theorem to figure out UT. And then I can also use Pythagoras inside here with P, U, and S to figure out US, and ST is the difference. ST is UT minus US. So I just need to figure out a few things. Now, how I go about doing that, it's sort of your choice. If you want to use some trigonometry, you can use trigonometry. I'm a big fan of the 30, 60, 90 triangles, and I know inside a right angle triangle is 60 degrees. Altitude makes 90 degrees. We're going to get 30 degrees left over. And triangles of this form, students of calculus tend to call this a special triangle. But really, I just remember the ratios are 1 to root 3 to 2, in increasing order being opposite the increasing size of the angles. So if I know the hypotenuse here is 6, I know that the shortest side is going to be half that, so 3. So now I know what US is. It's 3. And I know the altitude is going to be root 3 times that shorter side, so it's going to be 3 root 3. And now I can figure out UT. UT squared plus 3 root 3 squared is going to be the same as 14 squared. So UT squared plus, this will be 9 times 3, 27, is 196. Well, we can rearrange that. And UT squared is going to be, I think it's going to be 169. I'm just going to grab my calculator out because it's been a long day. Yeah, 169, because all the numbers are nice and neat. So square rooting that, UT is going to be... Oh, my pen has stopped working for a moment there. Let's see if we can bring it back. There we go. Oh, spazzed out at the last second. As I say, it's been a long day, not just for me, but also the electronic pen I use, the unsung hero of the math videos. UT here is going to be 13, and so now we can figure out ST. ST is UT minus US. It's going to be 10. And 10 is answer of D. All right. So that's question 19. One more question to go in part B, question number 20. Feel free to join me for that in the next video. Until then, take care.